Things to know about blender.
Okay.
That is definitely a thing that you can do with a blender, yes. Okay, now that we're 2 minutes late, hello everyone, this is Blender. Don't worry, we've got time to get through all these slides, and actually that was a total lie because I'm on under 60% battery right now. We'll see how this goes. So part 1, Blender is a very spooky program. There are a lot of options and not all of them are immediately useful. And this is perhaps the most important thing that I thought to mention to people who are just starting out in Blender, because you just open the program and it gives you choice paralysis immediately. And if you try following any of the tutorials that people have posted, they almost always get immediately into keyboard shortcuts, and that's not necessarily the best option for onboarding people. So to use an example, this is a different program. This is GIMP for image editing. I've used this for a while and it has a similar problem of having a whole lot of options and you don't know if any of these are actually useful. So I invented a nice little chart here to give you an idea of how useful things actually are. And as you can see, not a lot of them are all that useful, but this is, of course, my opinion, but it is some kind of guidance for what my kind of workflow looks like. So we can apply this to Blender, because if you look at the main window of Blender here, this is a mess. And it's not even that much of a mess because we can go further into the menus and it gets real bad real fast. Look at all of these options. What is this? So from here, I want to do the same thing in order to kind of demystify this, because look, you have a lot of options here, but a lot of these I have never touched and kind of don't care. They probably have some use for someone, and that someone is not me. But as I'll get into later in this one, there are about 20 different ways of doing exactly the same thing in a lot of these programs, which is why they have all of these. Someone thought, oh, this is just a way of doing it that doesn't make sense for me, so I'll invent my own way of doing it and then put it in Blender, and then they put it in Blender and it confuses people. So in case opening up Blender is scary, this could give some guidance of not everything is immediately useful or useful at all. I don't know if that helps. Is that helpful? Question to the crowd. Okay, cool. So yeah, that also applies to the whole modifiers window. We can talk about modifiers, but that's a whole other workflow that I'm not entirely covering right here because, again, there are multiple ways of doing the same exact thing. And one of the most powerful features of Blender as a program is that it is so powerful it does so many different things, in that it essentially just has a set of tabs between like laying out your scene and modeling and animation and UV editing and, you know, like texture painting, weight painting, all these different things. And those are all just different tabs in the same exact program. You don't have to close one, open up another one, worry about file porting between them. And even though Adobe has tried to make that a seamless process across all their programs, maybe if you have to invent a dedicated suite of tools for porting files across different applications, maybe you should rethink whatever it is you're doing. Maybe that's just a hot take. I don't know, but that's how it seems like to me. So it does a lot of things as a program, and we do not have the time or the battery percentage right now to go over all of them. So for the sake of argument, I'm only going to be doing these two. I hope you'll forgive me, but this is a lot of stuff, and I am not experienced enough to teach you about all of these things. Specifically rendering. I have done almost no rendering in Blender. Please don't flame me for that. But modeling. So this is the old truism that I mentioned before about if there's one way to do something, there are about 10 ways to do it. And the important part is finding out what makes sense to you personally. Because if a way of doing things doesn't make sense to you personally, it's probably not all that useful. So even for making a whole hexagonal cylinder here, you could go for something like a cross section here and then rotate it around 360 with some extra, like a number of sections equal to 6, and that will get you to this kind of cylinder. You could go for the preform of the bottom here and then just extrude it up. That's another way of doing it. That gets you the same result. Or if you just want to go absolute crazy, you could make a whole preform there. The one part of this I didn't include was like extending it down so it's actually a physically present thing rather than just a plane with a hole in it. But if you extend it down and then use this lovely little Boolean modifier, it'll take whatever is in that extended cutout thingy and then just cut that out of the cube there, and it'll get the same result, trust me on this one. There was not enough space on the slide to do a full visual demonstration of that. And there are a lot of slides in this presentation already, but I would like to give some shout outs to hidden gem tools that some of these get a lot of press and some of them do not at all. I'm looking at you, join tool, the fact that you're literally only mapped to a keyboard shortcut and do not even get an option in the tools menu. All of these other things have an icon in them because they actually have their own option in the little sidebar tools menu, except for join, which is one of the most useful things that I discovered. And I'm actually kind of salty that I didn't have access to it when I first started because it buried under a menu and a keyboard shortcut.
That would be so fucking helpful.
Yeah. Yeah, the whole point of this is that if you set, where's the chalk? Why is there no chalk? So essentially the point of join is if you have a surface and say it's one of these, you have a vertex here and a vertex here, and there's no connection between them, but you want there to be like an edge connection between them. Normally, if you're not using join, what you would have to do is delete this face and then like literally select all of these, make a new face, and then make a new face here. So you have to do a whole bunch of stuff. Or if you're using join and this is a face, you just select two and then hit join and it'll put an edge there and separate it into two faces for you. This has saved a lot of time, and I don't know why they made it not a default option for the tools, but they didn't. So hidden gems. Other things we have, some of these get a lot of press, like extrude. It essentially just takes a little face and then lets you extend it outwards. I don't know if that's self-explanatory or not. Should I explain that? Okay. Got inset, which I tried to have the images here explain them visually, but I don't know how effective that is. Do people have questions about what these do?
So inset like pushes in it, or does it like make like a bevel around that, or what does it do exactly?
It makes like a new subface within that one that's actually in the same plane.
Okay.
So as you see here, like we initially had this outer square here, and then we're using inset to make a smaller square in there while it's still flush and nice.
That makes sense.
This can be used for a number of things.
Could you combine that with extrude?
Yes, that's actually how I got this smaller square to be extruded instead of the whole face, is I inset it first. And yeah, that's. So yeah, this was a small little demo model that I made specifically for this presentation. And just to kind of go over the workflow, so I'm gonna try and stop the share here. And open Blender. Really should have prepped this beforehand, but we got here and we're here now. I don't know if this is not showing on the recording. Please stand by while we actually get the thing. Yeah, there we go. Yeah, go back in and share screen again. Yeah, so this is the end result of that whole thing. It's a nice little one. I'm actually gonna make it not visible here because we're gonna start over again. And essentially, we're just like gonna add another basic cube here. And then we're just going to mess around with it. I'm personally gonna scale this down a bit. I kind of like using the default tools just because I'm me, but that's like, I don't know, all the tutorials I found don't tell you to use the basic tools, and I don't know why. Well, yeah, you have all your basic operations like scale, move, rotate. That's these three, the core ones. Transform is all of them at the same time in case you want maximum visual output. It's just another way of doing the exact same thing. Other options that are kind of a hidden gem, but if you have. Is this even an option in the submenus? But there's an option for if you do Shift D, then it essentially lets you duplicate the thing that you just made and drag it around to a new position, and then you click and it pastes. And again, more things that Blender does not tell you about, even in the tiny little menus there. Another thing it doesn't tell you about is a little window where you can manually adjust the position of things, which that would have been helpful a while ago because I remember having to Google search exactly this when I was starting out. So you can set the center position of all the vertices that you currently have selected, which is nice. I love this little orbit gizmo for looking around. This is probably my favorite 3D orbit gizmo that has ever been made. But you just click one of the axes here and it will snap you to that view there, which is nice. We're moving. One thing to note about some of these tools is they have a little mixture. So they'll usually have kind of, they'll have axis specific moves, like you can highlight one of these axes in order to rotate it along that axis specifically. Or you can just, they usually have a kind of omni mode, which lets you just kind of trackball it, at least for rotate. Or position, the white one here is the omni for all three axes at the same time. They also have planar for two of them at the same time, which might not be helpful right now, but they can be helpful in some scenarios. So again, more tools for the toolbox. I don't know if this is overwhelming. But essentially, we're just trying to make the whole hangy. You can also hit X, Y, or Z in order to lock movement to a specific axis or whatever. That's been very helpful to make sure you don't have to go back and realign things afterwards. Selecting vertices specifically can be a little bit janky because if you just try to do a box select there, it'll only do it on the front side of the shape and not on the back side. So one tip for that is they have a little X-ray mode there, so you can go in and then.
I just went to wireframe.
You could also do that, but that's just because wireframe enables X-ray by default. Yeah. But yeah. This is probably gonna take a lot of time, so I might as well move on because we have other things to do, but that's kind of some of the basic modeling things that we can do. I should probably show off more of those hidden gem tools here. If I have time, I'll try to make time. Options here for selecting vertices, edges, and faces, respectively. Screen brightness is so low I can't see my cursor. And bevel. And then if you ever want to change one of the actions like this that you're doing off of default settings, they have an optional settings menu here that they do not tell you exists, and it's just like hanging out at the bottom left.
Like
Because
settings.
yeah, basically it's like collapsed by default, but if you want it to go from like, this is your standard bevel, but if you want to go for more of a chamfer effect, you could enter more segments like 3 or 6, and that makes it a bit smoother. Yeah, like that. So if anyone has used Fusion 360 and was wondering where the chamfer tool went, it was in the bevel tool the whole time. So yeah, that's about what I have for basic modeling. I'm gonna swap back to the presentation now. Why is juggling Zoom like this? See, this just forces you down a one-track mind of only ever doing a presentation or only ever doing a demo. Texturing. One of my least favorite things to do is after you're done with the model, you have to do all the legwork for actually putting a texture on it. There are ways to do it that are less painful. This is the kind of older / retro way of doing it, which is the way that I did it for the robot, just because I wanted to be like that. Where essentially you make the texture file first, and then you do all the legwork in order to map it onto the models that you made. This isn't necessarily the most efficient way, but this is the way that other games have done it. This is specifically a DS game. If you're wondering why the quality on this screenshot is so terrible, that's source resolution. Aren't DS games fun? I feel like, I think it's actually a fact that the Nintendo DS is one of the few game consoles that actually has a hard cap on how many triangles it can draw. Weird gaming facts. I don't know why they made that, but they made that. But the more contemporary way of doing the texturing is kind of like the texture paint method, where you make the model first, and then you just use a kind of default UV unwrapper script or whatever in order to unwrap it into a flat texture map, and then you use a dedicated tool like either Blender has a texture paint mode, or you could use something like Substance Painter from Adobe in order to actually like paint the texture onto the model in real time, which should be cooler, except for the fact that it's kind of janky in Blender. From my own personal experience, it could be better if you're using something like a drawing tablet where you can actually have dynamics.
And if you're like pixel art enthusiast, Sprite actually can integrate with that, so you can do it real time.
Wait, really?
Yeah.
I didn't know that.
It's pretty.
Well, I learned something today.
And it's a Steam game. I had no clue it was a Steam game.
Oh yeah, that outputs a file that looks kind of like this, which if you're trying to get very specific kind of images in afterwards, this can be a bit to deal with. This was an example model that I made a couple of years back, and I was trying to add in this little number here in post because, again, I was having issues with the default Blender texture painting. So I tried to add that in post, and it was a bit difficult given how much of the weird angles that it printed out on this one. But yeah, so texturing essentially just lets you go from the whole basic gray model to an actual textured looking thing. Why must the swapping be so terrible? Okay. So I'm just gonna edit. I might as well just go back onto the actual model that I have made here. So we have our basic model here with all our geometry, and one thing that they don't really tell you is that you have to actually do some legwork on this model in order to get it ready. So I have more slides about that, but essentially you have to put in a whole bunch of, these are called seams, where you essentially just go into edge selection, and then you select an edge, and then there's an actual mark seam option. Again, there is no tool for this. Get used to searching through menus. Blender is fun like that. But yeah, you can mark things as seams and then clear them as well. And that essentially just lets you get the model ready for the unwrapping process. And then once you're done with all that, you can select all of it, and then
Does Blender automatically try to put seams in, like, or do you have to do everything? Is it
no, you have to do that all manually. It's painful. This is why I hate this process.
for that, or
Hotkey for what?
like putting seams?
I want to see if there's a, I don't remember there being a hotkey for it. There's no hotkey for it.
It's set up, can't.
You, like a lot of programs, you can set hotkeys for things. So that is probably a thing that you, I just haven't done it. But yeah, and then it's just the UV option in edit mode, and then you can UV unwrap it. I'm not gonna do that because I already had a pretty meticulously set up UV map for this. If I can get the zoom settings out of here. Yeah, these are all the tabs here. These are all the things that Blender can do, but right now we're gonna look at UV editing. Because this is where we actually, I did the thing of making the texture sheet in advance. And I'll be getting more into like the why and how of marking those seams later in the presentation, but for right now, this is kind of a demo of, we look over all these. Yeah, you can see how all these little shapes here correspond to specific geometry on the model itself, so best way to demonstrate that is go into face mode, and then it actually lights up the corresponding things on the UV map, if that makes sense. So this is, if you ever wondered how it knows to map which part of the texture to which part of the model, it's this. This is how, UVs are how. Where essentially you just have a flat projection of that piece of the geometry that then gets overlaid onto the texture, and then that's what it draws. So getting back to the ever promised why. This is a very disjointed meeting. I apologize for that. So yeah, that's the goal. How we get there is UV unwrapping. So the best example that I could find for this was papercraft, because it's essentially exactly this. You take a flat piece of paper and you try to turn it into a 3D object. We're essentially doing that in reverse when we're doing UV mapping. We're taking an existing 3D object and trying to turn it 2D in order to apply a texture to it, because the texture is always 2D. So the main way we do that is seams. And the difference between seams and sharp edges, because there's also, and I think there's no hotkey for marking sharp, but sharp edges are also a thing, but that's mostly there for like if you apply smooth shading or a modifier to something in order to smooth out the geometry. The sharp edges marker essentially allows you to say, hey, stop doing that. I want this one to be all crisp. That's how you do that. Doesn't get quite as much use in things like hard surface, because there are other ways, like hard surface modeling is a whole different workflow that is out of the scope of this presentation. I don't have a counter for how much battery I have left here, but the whole MO behind how you place seams is that these are the two rules that every UV unmapper follows, where you use seams in order to divide two edges and make sure that they don't touch each other at all when the final unwrapping happens. And if you don't do that, then they are guaranteed to be next to each other, which explains some of the jank behind. So say we have a model like this and we want a different section of the texture sheet to be used for this little earpiece as opposed to the general side of the head here. That's less of a good example. So say we're looking at the front of the face and we want it to be different from the top of the head here. If we don't do any of the seam marking, it would try to unwrap this cube such that every single face is touching like the other four adjacent faces. And it tries to do that for all four, for all six of the faces at the same time. So it mostly just kind of mashes it down into a little bit of mush. And it's difficult to explain without just showing it. I should probably just give a demo of that. But essentially, marking seams is how you get the usual kind of cross-shaped unwrap for a cube. The shape like that. So you have these here. So this would not be a seam and this would not be a seam here, but all these outside edges would be, which is the backwards way of explaining it. I need to stop trying to rely on terrible visual aids when I have far better visual aids for this one.
At the cost of going through Zoom.
Here, shares.
Actually, that's a good idea.
For things you don't want to do.
You know what? That's a good idea, actually. Now you can see my terrible battery percentage. We're at 50%. All right. Zoom settings, why are you like this? Okay, so going back. turning off the actual armature doesn't turn off the renderer for the thing. I'm gonna delete that cube and add a new cube, because we need a new cube for this demonstration. So we have a cube here. We're gonna go in and just unwrap that. Oh, it's actually smart about it. I lied, Blender is smarter than I gave it credit for, it did this automatically, but like, you know what, Blender, you deserve applause for that. I was not expecting it to do that, but if you have something more complex, like I could probably just. I import a model here. What do I have on hand?
Blender monkey, right?
Oh, yeah.
Oh, yeah, we actually have a complex mesh that we could put in here. Zoom settings, why are you always where I don't need you to be? But yeah, we can have the lovely, I forget the monkey's name, Suzanne or whatever. Yes, Blender monkey here. Unwrap it.
Oh, yes.
What is that? What is this? This is not useful. So yeah, this is what happens when you don't mark your seams, is you end up with garbage. And you can see where that's getting you.
What happens if you put the texture onto it?
That's a good question. We could probably make a new material here. Image texture.
Oh,
Oh. So-
Over the truth.
That is terrifying.
Doesn't like that. Doesn't like that.
Smiles through the pain. So yeah, that's the importance of UV. The importance of seam marking that I wish people had told me before I got a result that looked like this initially. Yeah. But yeah, that's the basics of how it goes from these two things to that thing. Oh boy, rigging, my other favorite thing. Rigging is essentially, rigging is how we do 3D animation. So it's a similar way of telling the computer what things go where. This, in Blender, it uses a little thing called an armature, which is based off actual wire armatures. They're used for stop motion animation. I don't know if y'all have done stop motion. I have in my earlier years, but they essentially look like this, and then you put like cloth or clay or whatever on top of this in order to make the character. But it's essentially the bones beneath it. They are actually called bones of animation. And then once you have that skeleton, these are the actual things that you manipulate in order to make an animation and in order to pose the character around however you want. Another important thing is vertex groups. These are the things that tell the little, I forget whatever system it is that handles deforming your model in order to go around these bones. These are the groups that tell that system what vertices go with which bone. That is the purpose of these. There. Blender, yes. Not you. Yes, armature. Look in here. No. Yeah, so these are all the little bones here, so I already have it set up for, you can move them all around. And that's how you pose the character, but in terms of how you actually make these, you can. Trying to do anything technical and talking at the same time is very difficult. I apologize. Let's just make Suzanne even more terrible. Yes, armature. It's right here. So I'm gonna do something terrible and have two bones here. There's a slight method to my madness here. But essentially, we're going to. You can also name your bones if you want. I'm not going to for the sake of, you know what, I might as well. The names are not important, it's just for readability. And then you can. Parent these together. So for armature deformed, this is essentially the subsystem that I mentioned earlier that I didn't really have a name for. That takes that armature and then takes a set of vertex groups and then changes the model geometry based off of that. I say changes, but it's more like moves around. And then I'm just gonna use empty groups here because I'm gonna do a moderate amount of tomfoolery. So here it auto generates our vertex groups here, and these are all empty, they have no vertices in them. So we can actually go in and then select whatever vertices we want in order to assign them. And now this is going to be even more terrible. Because we can go back into making a pose and say we want to. Yeah. Nightmares, but you get the idea, right? Like we have our two bones and then. It's deforming them based off of which group we assign them, yes.
What happens if you assign versus two different armatures? Or-
Armatures or bones?
My bad.
Bones, we're actually seeing that right here. Where if you notice any of the stretching here, like if we rotate it even further. Like this stuff in front that's deforming a bit and on the bottom is because I was kind of sloppy in my selection and multi-selected these. So if you have something that's in two groups, then it will essentially treat them as being like a half weight in each group. So it essentially just takes all the groups that it's in and tries to find an average point between all of them, which is how you get the crazy stretching here. Boy, you came in at a great time. Want to see what terrible things we're doing to the blender monkey today? Isn't this fun? But yeah, that's what happens when you assign it to multiple bones / vertex groups at the same time.
That's a good thing.
With your robot, you had a neck bone and presumably no neck on the robot. What would be the benefit of that?
That is mostly, I added the neck bone specifically so that you could pose the neck without it actually changing any of the geometry. So it essentially exists in order to get the head bone in the right place and orientation. So like you can have the neck slightly tilted back so that it'll actually physically move the base of the head bone back a little bit. So that it's a little bit more natural for even if it doesn't have a neck and there's just empty space there, it'll still get a more natural look of if you're posing, if that makes sense.
So you can have bones without any.
Yes.
Okay.
That's what we had by default when we added the thing with no groups, so that all the groups were empty, and if you changed the. Go back. Right. Go back here, and if we go to. I forget. Which place, oh, it's because I don't have the actual model selected. Okay, if you're not a dingus, then go and remove. Select all those and then remove. And we go back, then normally it would be deforming because we have an actual pose on this one, but here because we took all those out, then it's not deforming anymore.
Cool.
Okay, other questions about this one?
Is animation like a frame by frame basis, or can you like somehow like automate it? Or do you have to go with like bone by bone technique?
It's automated by default, and I can get into that because animation is based off of keyframes, and keyframes are essentially little moments in your animation that change some property of something. So usually that's like the transformation or rotation of some bone. So you could have a keyframe of your arm being here, and that's a certain set of data for these bones here. And then if you wanted to move it, like say we wanted to hinge it in, then what you would essentially do is just create a new keyframe at some later point, and then set the actual bone values to be like here. And then it would start out here at the first keyframe, and then you press play, and it's just gonna automatically interpolate over to that second keyframe.
Automatic, but you still need to like.
Yeah, and the actual method that it uses for tweening between those two things for like what curve it follows and all that is a whole nother subject in animation. And some people actually chose to go without the automatic interpolation. That's what Arc System Works did when they were working on Guilty Gear XR to Strive. In order to get more of that choppier hand-drawn feel, they actually cut out all of the automatic interpolation for the animations and had it go on a strict, like, this keyframe on each frame basis, which is a whole lot of extra work, and I don't know what specific black magic wizardry they did in order to do that, but that's what they did because it was more for their aesthetic choice. What other things do I have here? I was not planning on covering animation in this one, but hey. Oh boy, we're actually, it's only 40. We're almost done here. I should probably go back and demo more things. I'm gonna go back and demo more things. Would that help people more if I went back and demoed things? Might as well go back and do a more in-depth demo on the UV mapping. Or I might as well ask the audience, what do you all want to see more of here? I know you came in late, you're probably confused.
Look, I don't know any Blender past like 2.6, so now I'm just like completely lost in the UI, but animation would probably be the thing I've been looking into, but I don't know what else.
I'm kind of confused for like a really complex shape like this. How would you decide where the seams are?
That's a good question. I might as well demonstrate on a slightly less complex shape like this one. This is the one I was saying before about the visibility not being parented. Okay, so on a slightly less complex one like this, it's more an art than a science, where a lot of people will tell you like just place the seams in places where the camera isn't gonna look quite as much and then just let it kind of smush around. But that's more people who are going for the kind of higher def materials where you can get that kind of stretching and it doesn't really matter all that much. With something like this that uses more pixel arty textures. Trying to talk and navigate the Blender UI. It is not fun. But essentially how these were placed was like on the head cube here, I essentially did the classic like cross unwrap where essentially the longest section is going along the crown of the head here. As for something like this earpiece, I wanted, like you could probably not have something like a seam here, but I chose to have one there specifically because yeah, like if you see that little glow on the antenna there, I didn't want that to get distorted with how it unwraps. Like it would essentially, if you didn't have that seam there, it would essentially treat this whole thing as being just kind of elongated and slightly stretched double cube. And if it did that, then I feel like it would have stretched this, it would have squashed this face in length while also stretching this one out. So I added all these seams along the way in order to stop it from happening. So that's essentially like, I don't want these two faces to be contiguous. I want them to keep their true length as it actually goes into the unwrapping process. Does that make sense? So that's a small example of the kind of reasoning that you end up doing. For a more complex shape like this arm here. I'm not entirely sure why there's not a seam here. That's probably just a mistake. There probably should have been, so these are mostly just isolated to the front face, side, other side, and then back are all their own thing that are isolated from each other, and that's based off of the fact that I did the actual texture like this with dedicated column sections for each of the arms and legs. So you have the like side of the arm and then other side, front, back, those kinds of things that are all lined up there. And I just needed a way to kind of isolate those four sides without them trying to, because if I hadn't placed the seams there, then Blender would have essentially taken, oh, hey, these are looking mighty triangular there, buddy. So it probably would have taken all of those and then put them in almost like a circular fashion. Or if you put one seam in there, it would have extruded them into a fan, which would not be as useful for what I was planning on doing with the texture, but that is a thing that you could do. Does that answer the question, or does that make it more confusing? Okay.
How did you get like the angled shapes, like when it starts like slants upwards? If you get what I'm saying? Like on the arms, like it starts like with a small section and then expand, like it gets like wider at the base.
Like with the actual modeling process, or? Okay, so as far as the modeling is concerned for that. Yeah, back to the cube. Like, if you enter edit mode, you gotta go back into object mode and reselect a thing before you can edit mode the new thing. That's kind of a jank way that Blender does things. But essentially, we wanted to make that arm. There are multiple ways of doing this, again. But the one way that I did it probably was just taking the cube here. And then essentially just taking the top and bottom ends and then shrinking them down once you have the whole shape all made. So you have the longer upper section. Then you take the two faces on top and bottom and then use the planar scale in order to shrink them down like that. Maybe that up. And then when it came time to like kind of mat down onto the body, I essentially just moved it into position and rotated it a bit. And that's how that arm shape got made, if that makes sense.
Yeah.
You move the 3D cursor now.
Which 3D cursor?
White and red things.
Oh, it's the thing that I always ignore. I know for a fact that there's a keyboard shortcut to change where it is. And I know that entirely because I've changed it accidentally. And that's the only way I have ever changed it, and I don't know how to change it back. So I am not learned enough on that specific topic in order to be able to answer that question with any amount of certainty. I apologize.
Last time I used Blender, moving that ring by default was set to left click. And right click was doing things.
Yeah, that's what.
Oh, there's a tool for that, apparently. This is a tool that I have never used, so. Does that answer you?
You can like move the origin around of an object to wherever your 3D cursor is. So if like you throw your object out into like space, and then if you center your 3D cursor, you can get it back.
Oh yeah, that's another thing to keep in mind with your geometry. Is that your geometry always has an origin. In this case, it's probably here at the intersection of these axes here, which might not be ideal. So there are multiple ways of changing the origin, but one way that you can do it is just selecting everything and then where is it? I was not kidding about the searching through menus.
What are you trying to do?
I am trying to find the set origin to geometry.
That might be
Maybe global under transform. And the little drop down menu to the right?
Well, no, that's just moving it around. That doesn't change the origin location for the object. That changes that moves around the actual vertices that you have selected.
What if you try selecting the origin and right clicking?
Oh, it's here. Yeah, you have to do it from object mode because it's an object thing rather than you selected several vertices kind of thing. But you can set the geometry to where the origin is, or you can set that origin position to where the geometry is, and several other options that I did not explore, but yeah. Basically, wherever, if you're in object mode, wherever the little move cursor is at the origin of that object. So we can also do fun stuff with that in edit mode if we want to do that. And now our origin is closer to where the upper arm should be. So that's also a way of doing it. That's far more janky.
Center of rotation.
Yeah, it's the center of rotation and scaling and all that.
What if despite it all, you want to UV map a sphere?
There are a few perfect ways to UV map a sphere, but one way that I recently found to do it is just to let Blender take the wheel, so to speak. So for UV spheres, this is a bit easier because it all goes to a point at the very top. So essentially, if you just unwrap that, it's just going to be like, it's probably just gonna cut and then like a map projection. Does that make sense? Kind of like the one with a whole bunch of slices near the top, like so. That's the way that it does it. So for some spherical shapes, that might not be ideal, but that is the default way that Blender does it. How does it do that for an icosphere? There are different ways of representing a sphere because none of them are perfect. Moment of truth. Oh, that's terrible. I don't like that. Why is it all okay, I know why it's all triangles, but that doesn't. This is not all that great for sphere unwrapping, so. As far as icospheres go, I have not worked with these a whole bunch, so I couldn't tell you. That's not a very satisfying answer, I apologize. I could go more into the actual materials part that I had at the end here, but that was more like an afterthought than an actual dedicated part of the presentation. How's our battery percent? 41%! We're not dying as fast as I thought we would. Well, yeah, do people want to hear about texturing and such? Because that was kind of an optional thing. Okay, cool. We got 10 minutes more for texturing. So there are multiple different textures that can go into a material, which is why texture and material sometimes get used synonymously, but not always. These are always the images that get put over your model. And a material is basically just a way of packaging all of these together into one cohesive resource. So these are the fancy little names that they have for it, which can essentially be broken down as base color, geometry faking. I don't want the gloss on here. I do want the gloss on here. Don't want the gloss, but slightly different. I want to make it glow and make the computer do it. That joke will make more sense later. But albedo or base color is essentially what color is the geometry before we apply any of the other effects like shininess or lighting or all of the other things. And that just gives us a nice base to work off of. So we have our nice little colors blocked in here like blacks and grays and blues here because very original color palette. But roughness and specular are essentially two sides of the same coin. One of them is trying to dull down the shading, so it's like, I want this to be a more matte surface, like kind of like this kind of thing. Or essentially anything that doesn't reflect light all that much. It's kind of, as it kind of diffuses the light, like frosted glass or whatever. And then specular is the opposite one for I want to go maximum shininess. And both of these are the first of what I would classify as kind of specialist textures, because you put them in after you put in the base color for these are all in grayscale for essentially a 0 to 1 value of how much do I want to apply the roughness modifier versus how much do I want to apply the specular. I don't know why they have these as two dedicated things that essentially map to the same thing. I don't know enough about rendering to tell you why. Do you have thoughts on this?
Pipeline, it's too much work for one thing.
Okay, that's the,
Computer dumb.
but yeah, this can be useful and sometimes it cannot. This one is very difficult to tell because on this example model, I had tried to make the little light emitters down on the tiny little black strip there be shiny. I don't know why I had the screenshot be from this angle because you can't see anything anyway. This probably means nothing to you, but it's essentially just the slider between shiny to matte. Like matte to gloss if you want to go for like varnishes. But yeah, that's the way of doing that. Normal maps are fun. Normal maps are the way that you fake having more geometry in your model than you actually do. And this can be helpful for saving on computation because it means there are fewer triangles to actually render. And the way that this works is essentially another texture that goes on kind of underneath. And this one is specifically meant to interact with lighting. In that, sure, you have the angle that your face is hitting the light from, but you also have the normal map information, which gives you more granular information of, okay, at this specific position, the light is hitting this specific angle in that normal map in order to kind of fake more geometry. So you can have things like, the usual example for this is bricks, where the bricks here, each one of these little bricks casts a tiny little shadow. And you can do that with a normal map, for this is all just one square in the actual model data. But if you use a normal map that interacts with the lighting, then it'll actually still show all of these shadows and the highlights from where it's hitting the light from the light up there. Is that a good demo?
Yeah, like for the, like to, I don't know, do more, if you did this in a game, it would be one completely flat plane and then you're projecting the normal map onto it and make it not look flat for free, essentially.
So yeah, kind of faking more detail without taking up more processing power. And this stuff on the right here is kind of just a bunch of nerdery that I thought was cool about how normal maps actually made and why they're always blue. In case you're wondering why it's always blue, it's because the color data is a lie. The color data for all of these auxiliary maps is a lie, because in this case, it's just storing a vector. And that vector is the actual, like, normal vector of, okay, how much calc has everybody taken here? Do I have to explain normal vectors? Okay, normal vectors. We have a lovely little perpendicular to the surface, right? Yes, it is perpendicular to the surface, and specifically, every pixel in this map has that vector stored in that pixel to tell you what the vector is that is perpendicular to that pixel at that position, and that's how the whole reflection thing works.
So like the color, like the RGB values represent the like vector like values?
Yeah, the RGB map to the XYZ components of that vector there at each pixel, which is a nice little repurposing of the 3-component color system. And this has nothing to do with anything, I just thought it was cool, so I thought I would share it.
The color is an afterthought, that's a reinterpretation.
Yeah,
You don't actually put the color.
you never, if you ever see a normal map rendered in game, something has gone wrong.
The colors are pretty, so.
They're very pretty, yes. And one of the ways that you can automatically make a normal map, because I have been suckered into making normal maps by hand, don't. I'll say that right now, don't do it. But you can essentially make two versions of the same model, a lower poly version and a higher poly version. And then there's this whole incantation that you can do in Blender that I have down here in orange that essentially lets you take the higher poly version of that model. It stretches it out a little bit to make a nice little layer over the lower poly model, and then it bakes it down into a texture. So that it takes all that extra geometry and then just converts it into normal map data with regard to how it would look when put onto the lower poly model, if that makes sense. So what you end up with is essentially the lower poly model with all of the fake geometry from the higher poly model. Yeah. Decals, this is old and I don't like it. We're skipping that. Emission maps are real fun. I still love messing around with these. These are essentially a color map. They are the color that you put on an emission map will actually be rendered in game. And these are essentially a whole map of telling the lighting engine of, hey, I get that you're trying to put on all these nice shadows here, but not for this texture. This texture supersedes all that and it does all the glowy effects. So this is the one where the images do actually explain it quite well, where it's essentially just an entire color map that ignores the lighting and renders anyway. So this is really nice for making kind of neon glowy effects. And if you want just no emission from anything, then you just put in straight black. I have an example. No, not stop. Zoom settings. Yeah, I had made some of these for intro to VR, so we have our actual base color map here. And then we have the emission map, which is more polarized. The black just doesn't have any glow on it, and this actually has the glow color embedded in it. That has nothing to do with anything. Actually, it does, but what, we're moving on.
Emissions are often the first step in doing like bloom effects, all that stuff.
Yeah, and then bloom you kind of can't do on the first pass because it's a post-processing where you essentially just have to take all the higher light stuff and blur it, because blurring requires that you have the entire scene rendered already, and then you go back and interpolate it all, but bloom is essentially glorified blurring, yes.
Bloom is very complex and is not worth getting into.
Yeah, PBR is a lovely little acronym for applying all of these effects at the same time in order to make textures more realistic. And this is an absolute fail whale of an example here because it's a fairly low poly model that I threw together several years back when I wasn't as experienced. So it doesn't really give you the full PBR effect, but if you're doing like professional processes for this, it can look very good. PBR is one of the primary things that people who do all the hi-fi, like Unreal stuff, love doing. And that's all I have for this presentation. Thank you all.
Yeah, the first one is